All right, for number 2, we have the carpenter is attaching 2 pieces of wood. The bottom layer is 1/12 inch thick, and the top layer is 3/4 inch thick. How thick in inches are the 2 pieces of wood combined? So again, when I see the word combined, what needs to come to my mind? Mensa. We're going to be adding those. And so as I'm looking through, I'm going to be combining the bottom layer with the top layer. So I'm going to go ahead and call this the the top layer. And I'm choosing to call this one the top layer because I'm seeing that I have the fraction 3/4. And this model is cut into 4 equal pieces. And I'm going to take my pencil and I'm going to quickly shade in 3 of those pieces to match the fraction. Perfect. The next thing that I want to do is I'm going to label this the bottom layer. The bottom layer is 1/12. So I'm going to write that fraction over here to the side, and I'm going to shade this model to match 1/12. I only need to shade in 1. Describe for me what you see here in these 2 models. What is it that you see, Jackson?
They're both, I've shaded and they're both like equal with 12.
Well, are they both equal in 12s? Is
Yeah.
this one partitioned into 12?
Yeah.
No. It's not currently partitioned into 12. And in order to be able to put 2 things together, we have to have common denominators, or we have to have common place value. This one is in 4ths, this one's in 12ths. It doesn't work like that, right? So I'm going to think right now about using my multiplication facts. I'm thinking, if I were to count by 4s, could I count by 4s and get to 12? Let's see. I'm going to write it very tiny here. 4, 8, 12. Did that happen for me? That means that I can count by 4s 3 times. That means I can cut each one of these 4ths 2 times to get 3 equal pieces. So I'm going to, with a heavy pencil, cut it 2 times. Now instead of 1 piece, I have 3 pieces. I'm going to do that again. And again. And even though I don't have anything labeled or shaded down here, I still have to cut it to make it match. Because you can't just cut half of a fraction. There's no such thing. And now when I look at this, I don't have 3/4 shaded anymore. I have 12 equal pieces. And I have 3, 6, 9 pieces that are shaded. So an equivalent to 3/4 is 9/12. I didn't have to change any of my shading, right? I just changed the size of the pieces. Now I actually have 12 and 12. We can write that expression. But I want to pause for just a minute because I'm thinking about realistically, 5th grade. We do not want to have to draw a picture every time we do a fraction. That's not very efficient. And in 5th grade, it's all about working efficiently, which means working to our fastest ability, right? And so what you need to know is that these pictures are going to kind of drift off, and we're going to use our multiplication and the wonderful 1. We're going to talk more about wonderful 1 tomorrow, but today I'm going to give you a little insight. If I were to write this down, I would write it down as 3/4 plus 1/12. And since we have the picture there, we know another name for 3/4 is 9/12. But if I didn't have that picture there, what I would be saying is it took me 3 counts of 4 to get to 12, right? That means that I could multiply the denominator by 3, and I can multiply the numerator by 3. And boys and girls, what is 3/3 equivalent to? Yeah.
9.
No, 3/3.
Oh.
Yes.
3/3 is 1 whole.
It is. And there is your wonderful 1, disguised as 3/3. And because we're going to multiply by our wonderful 1, we can get a new equivalent fraction name called 9/12. Because 3 times 3 is 9, and 3 times 4 is 12. Now, there's no need to rename 1/12 because it's already in 12ths. And if I slide that down, now can I put all the 12ths together?
Yes.
And how many 12ths do we end up having? The Ryan. 10 12ths. So today I'm going to leave it at 10 12ths, but know that tomorrow we're going to come back and talk about 10 12ths because we can't leave it like that tomorrow. But today's lesson is just really about combining fractions, so we're going to keep it easy and light. Look at the number line. Half of what we need to do, I might need to take this. Let me pause this. Look at your number line and tell me, how is this partitioned here? How many equal pieces do we have, Phoebe? We have 4. So I'm going to label this 1/4 of the distance, 2/4 of the distance, 3/4 of the distance, and 4/4 of the distance. And just like my picture above was cut into 4ths, we know that we can cut each 4th 2 more times to get 3 equal pieces, right? So I'm going to take my pencil or my pen, your pencil, my pen, and I'm going to cut it 2 times to get 3 equal pieces. I'm going to cut 2 more times, 3 equal pieces, 2 more cuts to get 3 equal pieces, 2 more cuts to get 3 equal pieces. And I'm going to label these. Now I have 12 equal pieces, so this would be 1/12 of the group, 2/12 of the group, and 3/12 of the group. And notice right now, another name for 3/12 is 1/4. Jackson, I hope you're labeling. Continuing to label, we have 4/12, we have 5/12, and we have 6/12. And 6 is half of 12. So is 2 half of 4. What is another name for this fraction? Yes.
1/2.
It is also called 1/2. That is what we would call its lowest term name. Continuing on, we have 7/12, we have 8/12, we have 9/12, 10/12, 11/12, and of course 12/12, which would be your whole. And taking, if you happen to have that highlighter or that marker, that's great, but you can certainly use pencil because we can use arrow. In fact, I may just do that. We're going to model what this looks like. So if I started at 0 and I went all the way to 9/12, I would be shading all the way to 9/12. And right there at 9/12, because we're adding, I'm going to put an arrow to show that this not is stopping here, but it's continuing on. We're adding to, we're combining more. And then I have one more 12th. One more 12th. And where do we end up being on the number line? 10/12. Should these match?
Yes.
Yes, your number line and your math should always match. If they don't, then something went wrong. Okay? It should all make sense. Okay? Now, turn the page. This will be the only one where we use the window pane. And then after this, we're just going to practice a couple of times. Okay? But I do want you to see how the estimate can help you think about your thinking. I need a volunteer to read this problem about Nicholas. Can you read it? Avika.
Nicholas ran 1/2 mile on Monday morning and 3/8 mile on Monday evening. How far did Nicholas run on Monday?
So we want to know how far Nicholas ran on Monday. We can just say he ran blank. Keep it light and easy. If I'm writing it, you should be writing it. We know in the morning, in the AM time, he ran 1/2 mile. We know in the evening, in the PM time, he ran 3/8. Remember those estimates that we did last week?
No.
We did them on the number line?
Yeah.
Yeah, let's think about this. We only estimate fractions to 0, to half, or to whole. So if you think about half, is that about 0, half, or whole?
No.
What is it? Abby? Half?
Oh, a half.
It's right at a half. Keep it easy. When I think about 3/8, I think, gosh, that's so close to 4/8. And 4/8 is called what? A half. Now when I think about putting these two halves together, I'm going to get 2/2, which is the same thing as 1 whole. Yeah?
Yep.
Are you with me, Maddie?
Yeah,
Do you need another pencil for a minute? Okay. So let's write this together. We have the fraction 1/2. We're adding that to 3/8. When I look at the denominators, do I have equal place value? No. So I think to myself, I take the lower denominator named Julian, and I think, can I count by 2s and get to 8? 2, 4, 6, 8. Can I do it?
Yes.
Let's write it out. 2, 4, 6, 8. I counted that 4 times. That is the magic number I want to multiply by. I want to multiply the denominator by 4. I want to multiply the numerator by 4. And once I do that, I am able to rename this fraction into 4/8. 4 is 1/2 of 8. I'm going to drag 3/8 down, so now I have only 8s. 4/8 plus 3/8. Can I put those together? Parker. And what do we get? We get 7/8. 7/8. Is that close to a whole?
Yes.
Oh, does this make sense then?
Yes.
We're going to drop that right back into our answer. Okay, turn the page. Well, look at there. It's a number line. It's a model. And whenever I come across models like this, I know you don't have sticky notes, but I'm going to cover them up. Because what I notice about models is boys and girls try to make the model match the number sentence instead of labeling everything they know and finding one to match what they labeled. So we're going to start with this number line, and we're thinking if it's 0 and it's 1, how many equal pieces are here? How can I partition this off? What could be that number? Everly?
6.
6. Take your pencil. This is 1/6 of the journey. This is 2/6 of the journey, 3/6 of the journey, 4/6 of the journey, 5/6 of the journey, and of course 6/6 is the same thing as 1 whole. When I look at these arrows, what does that tell me about these two amounts? Yes, we're adding. We see it start at 0, it goes, and then it's continuing on. So I'm going to go ahead and write adding. What are we adding? I'm going to go to that first arrow. What is this value right here from 0 to the point, to this arrow right here? Caleb Harrison. What is the value that goes right here? 2/6. Everybody write 2/6. I'm going to cover up that first part, and I'm going to think about the rest of my line. I'm going to count it because it's already partitioned into 6. I need your body to turn around. I'm teaching this direction. I am not over there. No one is over there. Your body is facing this way. Turn. Move your stool over so you don't kick him in the face. Thank you. Okay. So we have 1/6, 2/6, 3/6. Do you agree that that's 3/6? So we're adding 3/6. What is 2/6 plus 3/6 going to give you, Parker? It's going to give you 5/6. Perfect. Now I'm going to step back, and I'm going to think to myself, maybe there might be another name for this fraction. Looking at this one right here, is 3 half of 6? Oh, yes. So we could write this as 2/6 plus 1/2 equals 5/6. Does that make sense? Okay. But wait a minute. When I look at 2/6, I think to myself, 2 is even. 6 is even. Could I maybe cut them by 2?
Yes.
We could divide the top number by 2. And if we divide the top number by 2, we must divide the bottom number by 2. Oh my goodness, there's that wonderful 1 again. This time in the form of division. 2 divided by 2 is going to give you 1. 6 divided by 2 is going to give you 3. And we could keep calling this 1/2. Is it still going to give us 5/6?
Yes, sir.
Yeah, the total did not change from the top.
Yes.
Now what I'm going to do is I'm going to peel back all this information. Find 2 that match what we have written. 1 is very obvious. What is going to be your answers that you choose? Ryu?
Yes.
B and D. Absolutely. That is probably the most missed type of question on a benchmark. I'm going to tell you that right now.
Yes, sir.
They probably will not ever give you one this easy. They give you like this. And boys and girls, forget that there are other names for fractions that give you that same total. Beware. Okay? All right. Turn the page. We just have 2 more and then we're done for today. You guys have done a fabulous job.
Yes, ma'am. Yes, sir.
What does the word sum mean? What does the word sum mean, Michelle?
The total in multiplication.
It means the total. So when I see the word sum, I think I need to add. I'm going to rewrite this out. 3/12 plus 4/6. And right away, I should acknowledge that are 12ths and 6 the same size pieces?
No.
They are not the same size. Can I take this lower denominator name and count by 6s and perhaps get to 12? Let's try it.
Probably.
I'm going to write it out. 6, 12. So I was able to count 6's 2 times to get to 12. 2 is the magic number. We're going to multiply the denominator by 2 and the numerator by 2. There is your wonderful 1 in the form of 2 halves. We're going to multiply that and create an equivalent fraction called 2 times 4 is 8. 2 times 6 is 12. 8 twelfths is equivalent to 4/6. We're going to go ahead and slide 3 twelfths down because it is already cut into 12 equal pieces. There's no need to rename that one. That would just be extra work. Now that we have twelfths, can we put the numerators together? And what could we call this final fraction? Yes. 11 twelfths. Notice I'm solving it kind of like GMA. That's going to help you when we get to having to regroup with subtraction.
Yes, ma'am.
Our last one. The word combine. What does the word combine mean again? Adding. We have 3 fractions this time. We have 1/4 added to 1/2
Yes, ma'am.
added to 1/8. When I think about having common denominators, common place values, do I have them right now?
No.
No, I do not. So we're going to think about taking this number 4, trying to count to get to 8. Can I count by 4s and get to 8? 4, 8. Yes. I'm going to write that out. 4, 8. How many times did I have to count by 4s to get to 8? 2 times. That's the magic number. We multiply the bottom by 2 and the top number by 2. We're creating an equivalent fraction. That equivalent fraction is called 2 times 1 is 2. 4 times 2 is 8. 1/2. Can I count by 2s and get to 8? Let's count. 2, 4, 6, 8. How many groups of 2 will give you to 8? 4. We're going to multiply that denominator by 4 and that numerator by 4. We can't rename one without renaming both. When we rename it, we get 4/8. And finally, we have 1/8. There is really no reason to rename that one. It's already in 8ths. And when we put all of those together, Amaz, what do we have?
We would have 7.
We would have 7/8.
I also have to say something too. It would also be kind of easier to figure out with the 1/2 because the 4 to multiply the 4 it was 2.